Today's lesson is 4.1, using graphs to relate to quantities. And so by the end of the lesson, you should be able to say that I can represent mathematical relationships using graphs. And so the warm-up is to kind of get the gist of what our words mean. So we need to know if the phrase represents an amount that's increasing, decreasing, or constant. And remember, constant is stays the same. And so stays the same, number one, we know it's a constant. Rises is increasing, drops is decreasing, and slows down is also decreasing. And that's essentially what we're doing today, is we're going to be looking at graphs or reading examples and figuring out what a graph would look like. Is it increasing, decreasing, or constant? And so to begin, we have to analyze a graph. And both of the graphs represent a car, and we need to give an example about what they're doing. And so when we're analyzing graphs, we need to look at not only our x, but also our y-axis. So think about that we're taking time over distance. So as time passes, our distance is staying constant. So the distance isn't changing as time goes. So this must be a parked car. And now if you look at the graph, we have time is increasing, and distance, though, notice, is also increasing. So as time increases, distance increases. And so this car must be driving away. And also notice that because it's a straight line, they're driving away at a constant rate. So they're moving at a steady speed as they drive away. And now in example 1, we're given a situation in words, and we need to sketch the corresponding graph. So the pelican, it flies above the water searching for fish, and we need to sketch its graph from takeoff on shore to diving into the water to catch a fish, and we need to label our sections. And so when you're sketching a graph in a situation, we need to first think about what are we sketching? What are our vertices? Or our axes, sorry. So if we look at time, we're thinking as time passes, how is our bird's altitude changing? Is it increasing or decreasing or constant? And so our bird is going to start at shore, and he's going to take off. From takeoff, he flies above the water looking for fish, and then he dives into the water. So we have our takeoff, we have our flying, and we have our dive. And there's our graph. And notice that I said that when he dove, it was more steep than his takeoff. So he had a more gradual takeoff at the beginning. He flew above the water at a level height or level altitude, and then he quickly dove into the water. And that all happened as time progressed. Example 2, go ahead and try on your own. The graph shows someone taking a walk in the neighborhood, and your job is to describe what it shows by labeling each part. Pause the video, go ahead and try. And if you look at the answer, he initially starts the process with the blue, where he walks at a non-constant pace, slowly getting faster. And then he stands still for a bit in the purple. And then he follows that by walking really fast at an even rate, stands still again. And then he changes directions. Now he's heading back towards home. And he's walking really fast at an even pace. And then he stands still a bit longer. And then he walks really fast and gradually slows down until he gets back to home. Example 3 says that each day several leaves fall from a tree. One day, a gust of wind blows off many leaves, and eventually there are no more leaves in the tree. And we need to choose the graph that represents our situation. So remember on each graph we're looking as time passes, how many leaves does our tree have? And if you blow a few trees off, and then you blow off a lot of leaves, and then there are no leaves, is our number of leaves ever going to increase in this first graph? No. Leaves can never grow back until the next year. So a few leaves fall from the tree. So that's going to be nice and slow, a gradual fall, which both of these have a nice fall beginning. And then you blow off a ton of leaves, so it's going to be even more leaves. But here it says no leaves are lost, so this one's not right either. So we blew off a few leaves, a ton of leaves, and then gradually it loses a few leaves until there's none left. No leaves left at that point in time. Graph B is our answer. Go ahead and try example 4 on your own and pause the video and then check back for the answer. If you read the situation, you should have chosen graph C. A steady increase means it's going to be in a straight line. Straight line increase. Constant is a level. Slowly increases some more, and then a sharp drop down. Example 5 says to sketch a graph for the situation. And so the truck driver enters a street, drives at a constant speed, stops at a light, and then continues. And what's most important, remember, you have to think about time in relation to their speed. So it's not distance. And so you always need to look at your axes first. And it kind of tells you down here what's happening. He enters the street. Initially, he increases in speed. So his speed over time goes up. He wasn't at a dead stop, though, because he had to turn onto the street. So it's going to go up a little on the side, and then his speed increases. Next, step 2, it remains constant, and then it decreases to a stop. Speed is at 0. Next, he increases from that stop sign, and then he remains at a constant speed. And remember, whenever you see this word constant, it's going to be a horizontal line. Go ahead and try example 6 on your own, just like the last page, and check back for the right answer. Notice that for my answer, the first thing I did was I drew a graph and I labeled my axes, time and water level, which it tells you right in this pit. You have to remember to label because we have to know what's happening in relation to our graph. And so it says he begins to drain our water tank, and so we know our water level is pretty high. It doesn't start at the bottom. We have water in there, and he drains it slowly at first, and then when he opens the second valve, it initially drains really quickly, and then he closes the valve, and it drains slowly until all the water is gone. And there is our graph. So now we need to write a situation for the graph. And the first step is always to look at your axes, because we need to know what's happening and what we're analyzing. And so we have time, and as time passes, we're looking at speed. And we have to look at all our sections of the graph and analyze the sections in step 2. And so we start at some speed, and then we slow down. We're at a constant speed for a while. And then down here, we're slowing down again. And so one possible situation is driving in my car. I slowed down because there was a tractor. And then you followed the tractor at a constant speed. And then you had to slow down again for a stop sign. And there we go. Next, you need to try this one on your own. Remember to follow our steps. So, first, identify your labels. Analyze your graph as you look at what's happening. and then come up with a short story to describe the situation. One possible situation you could use to describe this graph is you could say that you were at the base of a hill that was a little off the ground, because you're not at a zero height, so you're a little above the ground. And then you could say you came to a really big hill, and you climbed it rather quickly. And then as you got closer to the top, you slowed down, and it was getting harder to climb as your height was increasing. When you got to the other side, you slid down the other side nice and quickly. My one final comment to make is that when you're describing graphs, if you see something with a curved line, like in this first one, remember it is a non-constant rate. So that they start slowly and they slowly are getting faster as they go. Here, whenever you see a straight line, it is a constant rate. So you not only in your descriptions need to say if it's increasing, decreasing, or constant, but you also need to say if are they increasing at a constant or non-constant rate of change. Is it a straight line or a non-straight line?